Please join me in welcoming Charles to the stage.
Be here at the first ever in Europe. And my name is Charles Woodward. I come from Finland. So our team, or VTT First, is the third largest research institute in Europe, if you didn't know. And our team has been around with AR technology already since the year 2001. So we are one of the first pioneers left in this area. Today we are some 25 people based in Espoo as well as Tampere, and mainly concentrating on industrial applications, maintenance, training, assembly. But one of our special fields is wide area tracking, which we employ both in industrial spaces, buildings, and public spaces. This image here is one of the examples from year 2010. We were already then operating without GPS or markers, having a SLAM approach to visualize, in this case, some new installations in a factory with SLAM-based technology. But going forward to what we are doing today, we want to have more automatic initialization than SLAM, so we are working mainly with point cloud technology. We have tools to create point clouds from photographs, or we use third-party tools. And based on the point clouds, we then have very fast, accurate tracking with fully automatic initialization, so the user doesn't have to do anything but to lift the tablet or look through the head-mounted display. This video shows an example for navigation at our offices. So at our cafeteria, the application helps the user to find some food items in the vending machines, showing which buttons to press, and then showing arrows where to find the next machine. So it's based on several point clouds, as you see on the right here. There are a few point clouds, and the system automatically detects the nearest one that has to be applied, and also switches between point clouds fluently. We also employ sensor fusion like accelerometers and SLAM if necessary to extend the tracking area from the point clouds. Furthermore, we have developed tools to optimize the point clouds, like number of points can be reduced up to 90% from original number. We handle different lighting conditions, outliers, and so on, and we have a Unity-based tool to do all this point cloud manipulation. Here, actually, you see a robot we implemented, which can be used to automatically create or take the pictures for point cloud creation, or on the other hand, to update the point clouds. Other methods we use for point cloud updating is use the user-taken photographs from the application. So if things change in the environment, we are able to update these things even without any extra effort. Some applications for indoor applications we have developed as a couple of examples. Building maintenance. We, in general, utilize the BIM model of the building information model. All the information that is contained there we can use for maintenance purposes or for renovation or even construction work. So in the video you will see a scenario of a maintenance person getting an alert that there's something wrong with the ventilation in the lobby. We have the BIM model aligned with the physical model and the point clouds, and this enables the maintenance worker to see the original building information plans as a 3D model, be able to click on the parts, so to have sort of X-ray vision behind the walls, what is there, and then in this case follow where the air is coming from and finally find the reason for the problem. Once the worker is ready, he can then freeze the image and start writing a report, so we have access to not only seeing the model but to interact with it. We are also experimenting with other means of tracking and AR interaction. One of the recent research directions we've taken is to apply AR social media to physical objects. Oops. Okay, I don't have a video here, but basically the user can take an image, photograph of any object and attach a tweet to the physical object, like in this example at the top, like a tea vending machine. And then others seeing the same machine later on will be able to follow up the conversation in Twitter, for example. But what we are doing today is more than the consumer side, so we are working with industrial companies to implement similar applications for maintenance people. Today, many maintenance people, as they visit the site, they, for example, leave post-it notes around. There are a lot of information that is not recorded anywhere, called tacit information, often counted to be as much as 95% of all information available. And we want to capture this information, having the maintenance workers inputting the tweets around the machines they are repairing, and even have the same information for the next worker available, or even at the other side of the globe with similar machine tasks. Then for outdoor applications, we have been one of the pioneers to work with architectural visualization. We have been bringing a mobile AR to real decision making in different cities in Finland already for some time. In the case here on the right, you see the Helsinki City Council evaluating some new hotel plans on tablet devices. We also have applied this in real estate marketing, like here in the images at the left, some real estate people are demonstrating the new housing to potential customers. That, by the way, shows a peculiar feature of mobile AR. So the weather is seldom good for mobile AR. Either it's raining or then it's too sunny, and always you have to wear the umbrellas. So we always hope it's sort of mid-cloudy when we do these experiments. For that reason, of course, data classes would be an improvement. Some other examples where we've taken similar tools up to citizens so that they can comment about the plans that affect their neighborhood. On the right, you see some farmers up in northern Finland seeing how a wind generator park will look when installed. And not just to comment on some plans, they can comment between alternatives and tell which one they would prefer. Then, not just the future and architecture, we are able to visualize the past, how things looked in the good old times. Like in the example on the right here, these are pictures from Turku, from Finland. At the top, you see how Turku looks today, and below we have an image how it looked when we had the old wooden buildings at the Turku center. Similar examples in Helsinki. We had a project with Helsinki City Museum And now not visualizing buildings, but old photographs. So we took some photographs of the museum archives, and with the point cloud-based tracking approach, we are able to find the closest photograph to the user's location, automatically augment it. And as you see from the video, everything happens very fast, automatic. Here, the environment has actually changed a bit and the user location changes, but the tracking still works. Here we see how Zeppelin visited in Helsinki in 1930. And same thing in nighttime, so example of the tracking working in different lighting conditions, even in nighttime. This tracking technology is available as our AR SDK, short from a library for virtual and augmented reality. With this, as we have experimented with different other trackers, we believe it's one of the best in the market. It's also available commercially. You can contact InGlobe Technologies in Italy with the AR media product family if you want to find out more. Alvar contains both marker-based tracking. Actually, in the image below, you see some NASA astronauts experimenting with Alvar. I'm sorry for the text box there, but anyhow, they are measuring the ground truth of a robot in a non-gravity environment. The robot actually has Google Tango integrated, but they use Alvar to get a more accurate measurement. And then it has the point cloud-based tracking that I have been demonstrating in my talk here. So if you want to find more information, here's the web address at the bottom where there are lots of other videos, applications, also industrial ones. And this concludes my talk. Thank you very much for your attention.